Now let's try to make some connections. The previous example showed a two-sided significance test because we did not care if the results were above or below the null value, just that the proportion of red candies was not equal to 20%. Recall that a confidence interval is a range of values that is likely to contain the true value of the parameter of interest with a certain degree of confidence. A two-sided significance test is a hypothesis test that assesses whether a given example is consistent with a specified null hypothesis. The relationship between the two is that if a confidence interval does not contain the null hypothesis value, then a two-sided significance test at the same significance level would also reject the null hypothesis. For example, if a 95% confidence interval for the mean weight of adult females is between 130 and 150 pounds, not including the endpoints, we would not be surprised if the true mean weight was as low as 130 pounds or as high as 150 pounds. However, we would be surprised if the true mean weight was, say, 120 pounds because it would be way far outside of this interval, and it wouldn't be contained within it. The confidence interval above provides a set of values that would not be rejected by a two-sided significance test with a 5/100ths or 5% significance level. The opposite is true too. If a two-sided significance test rejects the null hypothesis, then the confidence interval that excludes the null value would be expected. For example, in the scenario above, a two-sided test with a null hypothesis equaling 120 would be rejected at a 5/100ths or 5% alpha level. In other words, confidence intervals and two-sided significance tests provide complementary information about the uncertainty associated with estimating a population parameter, when a confidence interval can be used to help determine whether a two-sided significance test would reject the null hypothesis.